Hello from Intellipaat, guys. The topic for today is HDFS, but before we begin, be sure to hit that subscribe button and click on that bell notification icon so you don't miss out on any updates from us. So, for the agenda today, we have firstly, we would be discussing what a distributed file system is. Then we will get on to the distinctions between a distributed file system and a centralized file system, which is very important to understand in order to know the advantages of the HDFS. Then we'll eventually get on to the HDFS, which is the Hadoop distributed file system used in big data analytics, and we will discuss why we use it in big data analytics. Then some of the HDFS components, the essential ones, the HDFS architecture and workflow. So without any further ado, let us get into it. So what is a distributed file system? A distributed file system can essentially be defined as a combination of multiple centralized file systems. So the primary selling point of a distributed file system is that it gives you the benefit of using multiple centralized file systems with increased storage capacity and increased processing power because you're using multiple servers. So you'll obviously get more server capacity, more server processing power. But the client does not notice all of this intricacy. The client only interacts with a distributed file system in the way that the client would interact with a centralized file system. This methodology also helps us to mitigate the load that is there on a centralized server system, because many clients are trying to access that one server at one time. But what happens in a distributed file system is that due to the load mitigation, due to the load balancing throughout all of the servers present inside the distributed file system, it mitigates the load. So it is very beneficial when we are dealing with multiple remote clients. The DFS also organizes files in a hierarchical file management system like you would see in any local file management system. So you wouldn't really notice the difference. And as I made the point, when the file is accessed from the server upon request, the file appears to be a normal file on the client's machine. So you don't see any difference, basically, is what this means to say. That if you are a client, you basically download a file from the server and the file appears as it would on a local file system from a centralized file system as well. So those are some of the primary selling points of a distributed file system. If we move on to the differences between a distributed file system and a centralized file system, we have a few. In a distributed file system, you basically have the use of autonomous components. So a lot of things are automatically aligned in a distributed file system. You don't really have to manually configure things while you're dealing with that server as a client. While in a centralized system, everything that is the configuration part of that server, the client has to deal with that as well. So basically the distributed file system offers abstract because a lot of things are automated in it, and the distributed file system can be built with heterogeneous technologies. So say that one particular file system could be a Linux file system and the other file system could be a Windows based operating system file system. So those are heterogeneous technologies, while a centralized file system obviously uses only one technology. The system components can be built exclusively. So while in a centralized file system, all of the users that are trying to access that centralized server have to use the same server resources. In a distributed file system, you essentially have the advantage of dedicating particular system components to particular clients or server requirements. So that is the advantage that you get in the distributed system. The most essential part of a distributed system, the most essential benefit that you get in a distributed system is that processing of data or processing of jobs can happen concurrently, or in other words, in parallel. While in a centralized system, you don't really get that advantage because depending on the hardware configuration that you have in your server, in the centralized server, you can execute jobs in a sequence or execute jobs in a very limited parallel fashion. So nearly not as efficient as a distributed system when it comes to parallel execution of jobs or concurrent execution. And the other main point that is there is that the distributed system has multiple points of failure and control, while a centralized system has a single point of failure and control. So what does that mean? say that a component in your distributed system fails. So even if a single component in your distributed system fails, your entire server can still function, because there are multiple components that are constituting your distributed system. There is no deadlock that has been created due to that failure. While in a centralized system, if the one component fails, the entire server comes to a halt, and it obviously costs a lot of commercial losses in certain regards, because you cannot essentially function like you normally would, because your entire server architecture has failed. And the other point is that there are multiple points of control in a distributed system, while there is a single point of control in a centralized system. So say if there is an attack on the system by a malicious hacker, so even if the hacker gains control on one of the components of your distributed system, you still have partial control over the other components that you have in your distributed system. So you can essentially gain back control. While in a centralized system, everything is operated from a single point. So if an attacker gets control over one point in your system, then basically your entire server is compromised for the time being. So these are some of the advantages of the distributed file system over a centralized file system. And this is the reason why most of the organizations today, most of the modern organizations use a distributed file system, because centralized file systems are going out of fashion. In fact, they already have, because it is not a recommended infrastructure to have in a big organization. So now that we know the differences between a centralized file system and a distributed file system, and we understand what a distributed file system exactly is, let us move on to the HDFS, the Hadoop distributed file system. So some of the points that we have here is that the HDFS is a file system designed for storing very large files with streaming data access patterns running on clusters of commodity hardware. So three things have been highlighted here. First is large files, streaming data access, and commodity hardware. So large files implies that the data that you would want to store inside of your HDFS is extremely large in nature and basically is termed as big data. So big data essentially means that the data is continuous and in large quantity. So you basically need a system that is storage capable of storing all of that data. And streaming data access would mean that the data could be in real time. Data could be being generated in real time, so continuous in nature. And the most essential benefit that you have for HDFS is that it uses commodity hardware. So as opposed to traditional distributed file systems, which use a dedicated server in order to constitute that entire distributed file system. So as we discussed before, a distributed file system is essentially a combination of multiple centralized file systems. While the HDFS isn't exactly that. It could be if we want it to be, but it isn't exactly that, because HDFS offers us a methodology in which we can use commodity hardware. So what does commodity hardware mean? Commodity hardware essentially means the systems that we use in our day-to-day operations, the systems that we would have lying around in our offices, in our schools, in our research facilities, the normal computers that we have. So what happens is whenever we are setting up a Hadoop cluster, we can essentially set up all of these nodes. So these nodes could be dedicated servers, which we discussed before, or these nodes could be commodity hardware, which are the computers that are present inside of our office. We can dedicate a certain portion of these computers that we have to our HDFS cluster. So we are essentially reducing costs when we are doing that because we are not buying anything new. We are not buying any dedicated hardware or expensive hardware for that regard for this particular purpose of creating a distributed file system to store big data into. So that is the advantage of using commodity hardware. So 3 points here: very large files, streaming data access, and commodity hardware. So all of these things are very, very beneficial when we are dealing with a large amount of data, which we are terming as big data. So the factors that are involved in the design of the HDFS: high throughput, hundreds and thousands of nodes, handling large data sets, portability across heterogeneous hardware and software. So high throughput means that since we are having these nodes in parallel, these can execute information in parallel. So the overall output that we get by using a HDFS over a traditional distributed system is very, very high. So one of the advantages in analyzing big data is that whenever we are getting high throughput, we are essentially performing that big data analysis a lot quicker, and we can scale up our HDFS to hundreds and thousands of nodes, because firstly, the addition of nodes is not expensive, because we are basically using commodity hardware for our nodes. Basically everyday use computers and laptops, we are using that for our nodes. So hundreds and thousands could be used for our single Hadoop cluster, and it is very easy to add a node, because HDFS basically handles all of these things on its own. Whenever we are adding any node to our cluster, we don't have to perform any specific setup for it. We just have to add it to our HDFS, and the HDFS scales up automatically in the background without having much configuration regarding that. So basically very easy to add new nodes. And obviously, since the storage capacity is really, really high, we can handle terabytes and petabytes of data because of the thousands and hundreds of nodes that we have. All of the nodes having a certain amount of storage capacity dedicated to the Hadoop cluster. So the fourth point is portability across heterogeneous hardware software. So the constituents of our particular server that we have, our HDFS, they could be of multiple operating systems. They could have multiple sorts of hardware and software. It doesn't really matter what operating system or hardware they have. They can be added to our cluster. So you might have noticed that if you are using a single node server, a dedicated server, there is a certain criteria of hardware compatibility that we need to have in the server architecture, but not in the case of HDFS. We don't need to have that. So these are the four design factors that were taken into consideration when. So here we can see our HDFS architecture. As we see here, we have a name node, and at the bottom we have 3 data nodes. So these could be any amount of data nodes. In this case, these are 3, and we can see the name node is storing the namespace information, the metadata for all of the files that are present within our data nodes. So if we just go through the workflow for a minute, now we can see that the exact procedure as to how data is written into the HDFS. In other words, when data is uploaded onto your Hadoop server, the client requests to create a file. The name node is contacted once a block of data is accumulated. So first the name node is contacted before the uploading of any file, and then the name node checks the statistics of all of the data nodes that are present within its jurisdiction. And then it responds to the client with a list of data nodes that are available to store the client's information, which have the space for it, which have the overall freedom to actually implement it. And then the data node receives data from the HDFS client and writes to local. So then after the name node has conveyed the information as to which data nodes are free in the Hadoop cluster, the HDFS client then writes the data to the data nodes, and then the data nodes take that data and write it to their local file system, because that is where the data nodes store their data, in their local file system. The important thing that is there over here is that the data is replicated. So what does that mean? So basically, we have 3 colors, right? We have our green, orange, and red. So as we can see, these particular blocks of data that we have are replicated across all of these 3 nodes. So once the client writes that data to the closest data node that it has, these blocks are replicated on other data nodes as well. So what this does is, in the case of the leftmost side data node going bad or malfunctioning, we still have the copy of the data that the HDFS client uploaded to this particular Hadoop cluster. So that is where our data replication factor comes in. So then the name node commits the file creation. So after the data node has conveyed to the name node that yes, the file has been uploaded and it has been replicated, all of the replication metadata and the file uploading metadata is uploaded to the name node, is given to the name node, so that the name node now knows where the data blocks start and end and where they have been replicated at what positions. So After that, the client gets the data node list from the name node. It reads the replica closest to the render. So depending on the latency that the client has with a particular data node, it either reads the original data block or the replica data block. So this basically depends on how close a particular client is from a data node. So it basically accesses that data from the name node and then accesses the actual data from the data node. So if we actually look at the procedure of how data is read from the HDFS, we can see that first step is that there is a read request for block A and B from the name node. That is step 1. Then the step 2 is basically the name node giving some metadata as to the IP addresses of DN1 and DN3, which are basically the addresses of data node 1 and data node 3, which would basically give the client the method to access these data nodes and get those block information. And after that, the third step is that the core switch will try to access data node 1 and data node 3 after the client accesses the core switch of the Hadoop cluster that there is. And after the core switch has been accessed for data node 1 and data node 3, it would now decide that yes, data node 1 and data node 3 are on rack 1. So then the core switch redirects the client to rack 1. And after the core switch has redirected the client to rack 1, the client is able to find block A and block B. So this particular data is then sent to the switch and then sent back to the core switch. And then after it has been sent back to the core switch, the client basically gets that information wherever the client is accessing the Hadoop server from. So the client only needs to interact with one particular interface, which is the name node, and the other interface, which happens in the abstract format of the core switch. So it doesn't need to get into where all of these racks are located and all of these informations that are available. The core switch handles that for the client. The client only needs to know which particular blocks it wants to access. So with that done, we basically now know how the HDFS works in order to process big data, in order to store big data, because essentially HDFS is just a storage unit. This is not a processing element. So in order to store big and continuous data, we need something like HDFS. So now let us move on to something that I would like to discuss with you guys. An investment in knowledge always pays the best interest. So basically what this means is that you can watch all of these videos on YouTube, all of these scattered content that is present throughout various websites, or you can access our Intellipaat blog or our YouTube channel for that matter. But in order to understand all of these concepts in a much more structured and organized format, where you actually have maximum knowledge retention, it is imperative that you actually invest in a course or actually take a course, not necessarily buy one, but actually get this information in an organized format. So if you head on over to Intellipaat.com and type in Hadoop in the search bar, click on search, you get all of these results. But the course I would like you guys to focus on right now is the most popular course that we have right now. It is a new course that we have created. It is currently really popular with a 5-star rating and over 1,000 learners. So this course is an actual collaboration with IBM. So what that means is that in order to get that IBM Big Data certification, IBM actually endorses this particular course. So the key features for this course are 60 hours worth of instructor-led training. So basically you'll be seated in live batches, live online classes with an industry expert, an industry professional in big data analytics. And that person would be teaching you live classes where you can ask live doubts. Whenever you have a doubt during that period of the class, you can ask that doubt from the instructor and that instructor will resolve it. So this is one of the benefits you would not get if you're actually trying to learn it from forums and online study material. So this is one of the key features. The other key feature that we have is 85 hours of self-paced videos. So if the instructor is going too fast or too slow according to your needs, so we have a self-paced videos bank for the particular topics. You can basically access that alongside the instructor-led training, which is actually recorded recorded for you to actually watch on later on if you think that you didn't catch anything while the instructor was speaking. Other than that, we have 120 hours of project work and exercises. So hands-on is very important. It is very imperative that you actually put in some practical effort in the course that you're learning. So we provide 120 hours worth of project work and exercises for you. And once you've done the certification, you can actually be provided with job assistance. Your resume could be forwarded to particular organizations, and depending on your interview performance, you can actually land the dream big data job that you may have. And other than that, there's a flexible schedule. So if your schedule is not matching with the batch time for that particular day, you can basically be shifted to another batch, or basically take your lessons again in another batch without actually missing out on the live training. And then there's a lifetime free upgrade. So that basically means that wherever there is a upgrade in the technology or an update in the technology, a significant update which changes the entire foundation, we update our course accordingly, and you can access that new course content for absolutely free. So there's a lifetime free upgrade for that. And there's 24/7 lifetime support and access. So once you subscribe to any of our courses, if you have a technical doubt or any other doubt, there is support for you. Our Intellipaat support team would be happy to help you related to your doubts. So some of the things that are covered in the course: the fundamentals of Hadoop and Yarn, very important. Setting up nodes in your Hadoop cluster using Amazon EC2. So primarily these days, Amazon EC2 is used for setting up your Hadoop clusters. So that is very important. HDFS MapReduce, Hive, Pig, Uzi, Scope, Flume, Zookeeper, HBase, all of the traditional elements that are covered in big data, very important as well. And then the new frameworks that are being used for big data, the modern frameworks like Spark, Spark SQL, and Spark Streaming, Data Frame, RDD, GraphX, and machine learning as well. And then after you're done with that, you can basically look at some Hadoop administration courses as well within this particular course, and ETL tools like Pentaho and Talent. And then if you want to get into the Hadoop testing part of things, you can basically use MR unit for that, and working with Avro data formats like real-time data analytics and real life projects using Hadoop and Apache Spark. So that is part of the project work that we have. And who can take up this course? If you are a developer or a system administrator, experienced working professionals, project managers, Hadoop developers, mainframe professionals, architects, and testing professionals. If you're coming from a BI, data warehousing, or analytics background, or you're a graduate or undergraduate who's basically looking to learn big data. So if you just go over, if you want to look at the course content in detail, you can download the curriculum or look at the abstract version of it from right over here. If you want to look at the problem statements that we have for our particular course projects, you can look into that as well, and look at some testimonies as well of our course reviews. So that is about it for our session here today, guys. Thank you for attending. And you can use the coupon code YouTube30, especially for our YouTube audiences watching here today, to get a flat 30% discount on not just our Hadoop courses, but all our courses. So if you can head on over to Intellipaat.com, if you're genuinely interested in subscribing to one of our courses, please use the coupon code YouTube30 to get a flat 30% discount on it. So with that out of the way, we are done with our session here today. Join us again tomorrow for a session at 1 p.m. IST. And these are the contact details on your screen right now. If you have any doubts, if you're looking to subscribe to one of the courses, or if you're looking to know the details of our courses, you can contact our course advisors or contact us at sales@intellipaat.com, or contact us on one of our numbers present on your screen right now. So that is about it from us. Thank you for attending this session. Goodbye. Hope to see you again.